Summer Web Boot Camp.
Okay, so we're going to talk structs and interfaces next. Structs should hopefully be much easier than pointers, okay? Especially if you've done any programming at all, they're going to look way more familiar. Okay, so although it would be possible for us to write programs only using those built-in data types, at some point it would become quite tedious. So here's an example program that does some basic stuff with shapes. Okay, so I'm going to have this distance formula. Remember the distance formula? Everybody remember that? You take x2 minus x1, y2 minus y1, and take the square root of it. This finds the distance between 2 points.
X squared equals y.
7th grade or something. And then this finds the area of a rectangle. You do the length times the width. And this finds the area of a circle. Pi times pi r squared. And then we're calculating that to find the area of a circle and the area of a rectangle. So we'll run that program real quick. So let's make a new folder. And we'll call it struct example. And then we will create a new file. Main.go. Paste that in there. Uh-oh. Wrong dashes. But otherwise that was right. And then we're going to run our program. So cd back up, cd to struct examples, and then go install, and then run it. And there we go. So we got 178.53 and a bunch of stuff. So that found the area of a rectangle. That was a 10 by 10 rectangle, and the area of a circle, which had the radius of 5. Okay? Everybody following the example here? Pretty straightforward, basic geometry, right? So what's wrong with this program is that it's really hard to see the shapes in here, right? Like, the shape of a rectangle is just these 4 coordinates, these 4 points of data, but I don't see rectangle here anywhere. I see it in the name of the function, right? So this is kind of a tedious way of writing the code. Now this is all we know how to do so far because we've got structs. That's the point I'm trying to make out. Okay, so a better way to structure this program is to use structs. So instead of having those 3 coordinates, those 3 points be separate, we put them inside of a circle. So let's make this type circle struct. Okay. So we're going to erase all this code. Actually, I'll just bring it down. Okay. So the way this reads is create a new type. That's the type keyword. Make a new type. Give it a name. The name here is circle. You can use the casing you want, but remember, things that are uppercase get exported, things that are lowercase stay inside with circle. And then it's a struct. Okay? So just to make this clear, you can make other types. You can say my int is an int. And this is like aliasing int to another name. Okay? So I can use a my int like I can int. You don't see that a ton, but I'm just saying you can create other types besides structs. But we usually use it for struct. So a struct is like multiple things put together. Okay? So we have a float 64, a float 64, and a float 64. And they're all like right next to each other. Okay? So how many bytes is that? 24, right? It's really straightforward. If you imagine we have this array, and we have x, y, and z, this whole thing is the circle. Okay? But we've given names to those locations. So we could have the equivalent of, this would be the same as the 3 float 64. And then we could, to get x, we could say at 0, and to get y, we could say at 1, and to get the radius, we could say at 2. But that would be annoying. It's better to give them names, okay? And so this way, we have given them a name. This is x, this is y, this is z. So struct, think of it as structure. It's structuring the data, okay? They call these fields. Notice each field has a type. Yeah?
Z should be R, right? just for clarity, you're making that assumption.
Oh, yeah.
Just for
Sorry,
everybody
I wrote
else.
that. I wrote that wrong. So,
It's just a match to struct.
right, that's the radius of the circle. And this is the position of the circle. Okay. Everybody following this structure? So I've created a new thing which is made up of 3 other types. So these are the built-in types. I've created a new type. Okay. So I'm adding types to my program. And we do that because it's easier to reason about the data when we can structure it. Okay, so the type keyword introduces a new type. It's followed by the name of the type, circle, the keyword struct to indicate that we're defining a struct type, and a list of fields inside curly braces. Okay, curly braces. Each field has a name of the type. So the name of the field is X, the type is =64, and like with functions, we collapse them, so we can also write this if we wanted to. That's the same thing as that. Understand? Okay, so how do we create a circle? The way we create a circle is like this. So I'm going to call this main 2 just so we don't lose it. So if I want to create a circle, I do that. So C is a circle. So in like Java, you would say new circle. In JavaScript, you do something like that as well. Right? But in Go, you can just say var C circle. And that creates a circle. You can also do this. C is a new circle. So what is the type that's returned by this? We just did pointers, right? So what was new? Circle. It returns a star circle, right? Because new takes the type and gives you a star of that type. So we say new int gave me a star in. We're going to say new circle gives me a star circle. Just want to make that clear, okay? If it wasn't clear. Anyway, so then the question is, if I create a new circle, what is the value of x, y, and z, or x, y, and r? Sorry. So I have this x in here, and this y in here, and this r in here. What are their values? Anybody guess what the values are going to be? Zero. They all default to 0. So if you want to know what the default value of your struct is, it's everything inside of it to their default values. So they all get the 0 value. Okay. So the 0 value of the struct is all the fields set to the 0 value. It's not what happens to be memory. It is 0. Okay. So a 0 circle is x is 0, y is 0, and r is 0. So how do we access fields? We access fields using dot. Okay. So that gets the x field of the circle, c.x. That gets the y field of the circle, c.y, and c.r. Okay? So let's run that program. We see 0, 0, and 0. So x is 0, y is 0, and r is 0. How do
Can you just print C?
we can just print C? It has a nice clean print. So let's look at that. I'm just printing C here. Let me clear that. So that's it shows you 0, 0, 0. It didn't put the names, but you get the idea.
But can I just bring up something? So we just defined a circle that isn't a circle because it has no radius, it has no x, and it has no y. So we defined a circle, but not mathematically as a circle is. Sorry,
Yeah, no, that's fine.
It's equivalent to an infinitesimal small circle.
It's a point, right? A point at 0, 0. No, we have a set of properties.
no, sorry.
No, it's a fair point. Okay, remember that when
It's a way of thinking, though.
Yeah.
You got to think. I'm defining something, yet it's not actually how we understand
Yes.
the circle to be.
Right, and that is a good point, is that when we're programming, this is an abstraction. I'm structuring data in a way that makes it easier for me to understand, but that doesn't necessarily correspond with what it really is. And particularly with math and stuff, we have like an uneasy relationship with math sometimes. Integers are not quite integers because they have a limited size, right? Floating point numbers are inexact, whereas math is exact. So we have that problem a lot, and there's another example. The radius shouldn't be 0, but it is 0. Okay. But we'll see how we can set it, and then it'll be more like a real circle. So here's another way we can create a circle, and this is way more typical. Okay? So if I want to change it so that I set these things, I can say, remember the shorthand, C, colon equal, and then circle, and then curly braces. So this looks like creating a slice. It also looks like creating a map, the same shorthand syntax, except instead of putting the values, we use the fields. So we say x is 0, y is 0, and the radius is, say, 10. Okay? Now that's a circle at 0, 0, who has a radius 10.
Now you're talking.
So if we print that out, we should see 0, 0, 10. There we go, 0, 0, 10. Okay? Everybody following that?
And then that array, it looks like an array. It won't switch around like some of the other arrays do. Because when we print arrays, they don't always follow the same order.
That's mapped, and no, they're always going to be in this order. Because this order is well defined. It's x and then y and r. I will say that the position of where these things lie is not necessarily, you know, we have that structure where I said they was like right next to each other. Sometimes Go will add space between them. It does that to align them for certain CPUs. But don't worry about that. That doesn't matter. Think of them as being right next to each other. Okay? They're just dummy data inside it. But it doesn't matter because you don't interact with the circle that way. You just go get .x, .y, and .r, and Go handles the messy details for you. Okay? So we can create it this way. It turns out we can also fill it in. We don't have to use the field names. We can say 0, 0, 10. And it knows which fields are which. Because the first one is the first field, the second one is the second field, the third one is the third field. That's okay for small structs. It's okay to do that. If you get a big struct, don't do this. Because it's confusing. It's hard to know which things you're filling in. Easy to make a mistake. And so, you know, clarity is more important than brevity here, right? So it's usually a good idea to just be explicit. Okay, so the other advantage of being explicit is we can leave one out. If I don't set y, you're allowed to do that. You don't have to set every field. So what happens if you don't set one of the fields? It'll start at 0. So that's pretty clear. It's very well defined what happens if you don't set one of the values. Okay. So they're pretty easy to make, right? So these are fields. So we can access them using the dot. So now we're going to add a method. So we can assign to them too. Okay. So we can access them using dot, and we can assign to them using dot. This is just like x equal 10. This is just like x, except we're putting it inside that circle.
You say now we're going to add a method?
We're going to add a method.
Okay.
So let's modify the circle area function that uses a circle. So first thing we need to do, we have this circle that we created. We need to create this function. Okay. So I had circle area. Right, and it took x, y, r. But now we want to take a circle. So the way we do that is we say C, circle. Okay. The r here is C dot r. And now we can calculate the area of the circle. So let's try that. Let me get rid of that. There we go. It calculated the area of our circle. I should make this, I think it was 5 in the example, just so it's the same. There you go, 78. So notice we pass in circle instead of the radius, because we get the radius radius is here. Make sense? So now we calculate the area of the circle. Got it? So now we can change the function again to be a method. So instead of circle area, we can change it to be like this. And then we can invoke it like this. Okay? So what I did is I added before the function name, I added in parentheses what's called a receiver. Okay? This is a pointer to a circle. And I gave it a name C. I didn't have to change anything inside the function because I'm still referencing C.R. Okay? In JavaScript, C would be equal to this. Right? Or in Java. And we can actually give it that name if that makes it easier for us to understand. That's what it's doing, okay? But we can give it any name we want. That's something Go allows us to do. So we're just going to call it C. Everyone understanding what I'm doing?
I don't get why the receiver.
The receiver allows us to call it as a method.
So the asterisk circle is, the C is the receiver, not the star circle?
C is the receiver.
Okay.
Star circle is the type of the receiver.
Oh, that's the type.
It's very similar to, if I show you the other one. Very similar, right? I gave it a different name, but I moved the first parameter before the function. And what that allows me to do is it allows me to call the function like this. I can say C dot the function. Normally I'd have to say circle area and pass in C, but this allows me to call it like this, okay? So that's the difference between a method and a function. Methods are attached to types. And they
So
allow you-
even if on line 15, the C, the func C, the little c was this, and then on 16 you have this dot r and this dot r, still on 24 you call C dot area because C on 24 is referring to C on 20, just
Yeah.
to disambiguate for some.
Yep. So this gets attached to this, so when you reference it here, it goes to this guy.
So this is a different star, right?
Nope, same pointer we saw before. It turns out in this case, we can do this, and that's the same thing. The reason it's the same thing is if we don't modify anything. We don't modify the circle when we calculate the area. We're just getting value. Okay? But, there's a typo here. It's more typical with a struct to pass in, to use a pointer as the receiver. Okay? Because if we modified, if we did C.R equal 100 or something, with a pointer, it's going to modify this circle. If it's not a pointer, it doesn't modify it, which is counterintuitive. Okay? Normally, when people are using methods, they expect if I modify the object, it's going to modify it for everybody. But if I don't use a pointer, it copies it, it doesn't modify it for everybody. Okay?
You wouldn't need on 16 a star in front of C dot r?
No.
So that would be the reason to use a star or not use a star, whether or not we want to modify
Yep.
only within the function, or whether we want to modify it globally for all time, or for,
Yep.
for the rest of the time.
Yeah, it's twofold. If we want that capability, also, if we have a large struct with a lot of data, by using a pointer, we avoid copying all that data over and over again. We're always referencing the same object, so that's a little more. So Go allows us, when we use a struct, when we do .r, it can be a pointer or not a pointer. We don't have to use star C.R, but it's doing the same thing. But it just makes it easier. We don't have to think about what it's doing.
Yeah, because in the previous example, if on 15, it would have been the
Right.
argument was receiving a memory address of some type, right? Then down below you do something like that on 16 to.
Right. So that's
just a Go syntax. Go takes care of that in the background.
so it's like the same idea. It's just it does it for us. So in practice, yes, we cover pointers. Yes, they're kind of important, but in practice, if you want to use a struct, you almost always use the star and the name of the type, and then just make it behave as normal. Okay, and it will do what you expect it to do.
All right. So I'm just like gonna say this, and I'm curious what your thoughts are on it. But it's almost like this is an object, right? Where we have something that we can define that has properties and methods. So for instance, we've defined sort of blueprint or even prototype or class, even though here it's called type circle, and we have the properties X, Y, and R, and then we've attached the function to all that, like a method, and we did that with the receiver, and that method function is area, right? So it's kind of like objects, except there's probably not, is there instantiation? And I guess so, you can make as many circles as you want, right?
Yeah, we
And
create
each one
circles
will
like
have- And each one will have unique parameters, but they'll all share the methods in common, so it's not like there's multiple copies of your methods. No. What are your thoughts?
No. So think of this as there are not multiple. The methods are not part of the struct.
Yeah.
The methods are functions which take as basically their first parameter the struct. Okay. Yeah.
Which area up here is the method?
The method is this one. So this is a function. This is a method. So the difference between a function and a method is methods have receivers. That's it.
How do
Okay.
you make a method receive more than one?
You can't. Well, a function can have one receiver, but it can have lots of arguments. So you could have, X, Y, Z int or something. They can take arguments, but the method makes it so that I can call C dot and then the name of the function. Okay. And then I would pass in X, Y, and Z. But you can't have multiple receivers because that wouldn't make sense. I mean, how would you do that? I mean, you'd have something like, A comma B dot. It doesn't even make sense, right? So you can have one receiver or no receiver, but you can't have two receivers.
In JavaScript, we use methods on objects, but here, and I thought maps were more like objects, structures are more like classes, right? Would that be fair?
So JavaScript does not have structs. It only has maps. Okay?
It does have maps.
I mean,
Objects.
objects, which are like maps in Go.
Yeah.
Okay? And what happens is when you do c.area, you are taking out of that map a value. That value is a function. Okay? And then you invoke the function. So this is very different. This is, I'm calling a function and passing in the circle to the function. Okay? Like I'm saying, this area and this circle area are very similar in the way they work. Okay? They look the same in the way you use them. I'm just saying underneath they're very different the way they work.
Is println a method?
It is a function on a package.
Okay.
So that's another thing. This dot has many different meanings. It can mean access a field. So here's accessing the field. It can mean invoke a method. Here's invoking a method. It can mean access a method, access a function inside of a package. That's what this is doing. You can also access variables. We saw that with map.py, right? I'm accessing a variable defined in a package. Got it?
So number 15 is a function. I mean, you declare that you use the method area in that function, right? Is that the difference?
So I'm creating an area method so that I can call it like this. So I can say c.area.
Okay.
And that gives me the area of the circle. And what it does is when I invoke that function, that method, it goes up to here and just runs this code and returns a float 64. So it just changes the way I called it. Before I had, circle area C, and now I have c.area. Okay?
I think this will become a lot more clear when you start to work with it and you build a couple of little examples. It'll solidify in your head more, like all things.
Okay, so let's go back to the text here. It's much easier to read. We no longer need the ampersand operator who automatically knows to pass the pointer to a circle for this method. So that's another interesting distinction. Okay, so C has a receiver type star circle. This is a circle. C here is a circle. I don't have to say ampersand C here. I can just say C dot array. And what it does is it takes the address of C and then invokes the function by passing in a circle. Okay. So this is the same as this. Those are the same thing. Understand? So typically, actually, you'd do this. Okay? So I create a circle and take the address of it. And so now this is a pointer to a circle, and I'm just going to use that everywhere. Okay? So think of it like this. I want to create a new struct. I usually take ampersand, the name, and then curly braces to set the fields. Okay. So we do the same thing for rectangle. We create a new rectangle and make the area function. So let me get rid of this circle area. Don't need him anymore. And now we're going to create a rectangle. Okay, so rectangle has 4 coordinates. There's other ways we could store this. We could store it with width and height, but we're just going to have 2 points that indicate where the rectangle is. And then we're going to calculate area. Here's the other advantage of methods. We can give the same name to the function because they have different receivers. Okay? So they both called area. That's handy. Before we had to have rectangle area, circle area, and so on. Now we just have area. But otherwise, the formula was the same as it was before. The distance between the points. And we have times width. Okay? So now we have a rectangle. How do we create a rectangle? We do colon equal and rectangle. And then we have 4 coordinates, x1, y1, x2, y2. So we'd say x1 is, say, 0, and y1 is 0, and then it's x2 is 10, and y2 is 10. It is a square. Okay, and then I calculate the area. So that's nice. That means the area for a circle, area for the rectangle has this nice symmetry to it, right? Same name of the function. Cool. Are we following that?
Where did you define the method of area?
Right here.
You defined the method of area twice. So you made it's a function?
Yeah, I created func and then the receiver. The receiver here is a rectangle. And then I gave it the name area. Down here is another area function, but it's a method on a different receiver. Right, so circle. So this is the area of the circle, that's the area of a rectangle. That's how you define 2 separate area functions.
And you declared them at the top of the whole page so that you can use them wherever you need to.
Yeah, so the rules for that are I mean, they don't have to be in order. So main could be way up here. They just have to be after the import. That's the only thing. And I think you have to have these after the type.
You can't do that with functions have the same name, right?
You cannot have 2 functions with the same name. So that's why methods are a little more flexible that way. Okay, you can. You can define a method before you define its type. I wouldn't do that. That's weird. But you can do that. You know, it might be more typical to see all your types at the top. You know, maybe you put all your types and then you define your methods. Up to you. There's no real rhyme or reason to it. But it doesn't change the functionality. Okay? So just remember, like that was the distinction I was making about the JavaScript Go. The top level here is not like code executing. It's more declarative. We're saying, here's some types, here's some methods, and that's why the order can be different. Because this doesn't execute anything. It doesn't execute anything until you go to main. And now it's executing. Okay.
So it'll look over itself multiple times. And
Sorry.
if you have main on top and then a function below that, and then say the second function it uses is at the bottom and the third function it uses is in the middle, does it run through the whole code 3 times?
It's like it is taking the whole thing built up a big, huge table to find things, and then it runs manually. So it doesn't matter where they were defined, it knows how to get to them. Okay. Remember, this is compiled, so it has the advantage of being able to parse everything, do whatever it needs to do, and then generate something that goes in order. So the order doesn't matter because it can figure that out. JavaScript has to go in order, and so you have to define things in order to use it. Okay. Everybody following this structs? So straightforward, you just have proper fields, and you use them very much like we saw before. You just use dot instead of the name. So what's the difference between a method and a function? Yeah, methods have receivers. Okay, so that's that question. I don't know if I put another question. I didn't. So, okay. The issue is that we kind of need to talk about these other things before we can really do example problems. And it's going to get out of hand quickly, probably. Okay, so this